Hello dear students, welcome back to NEET World. So this is our session on hydrocarbons for EAPCET 2026, okay, and this is our session 2 on hydrocarbons. So in the first session I have discussed what exactly hydrocarbons, their classifications, and then next we have started preparation of alkanes right now. So where we have covered preparation of alkanes using different reactions, for example Sabatier-Sandrens process, that is what reduction of alkenes and alkynes gives alkanes right now. And the next one is preparation of hydrocarbons like alkanes using Wood's reaction from alkyl halides. We have discussed about Wood's reaction and reduction of alkyl halides using lithium aluminium hydride, or reduction of alkyl halide using zinc and acid catalyst like HCl will be used here, that produces respect to alkane. This discussion we have completed in the last class. Like see, if you take any alkyl halide like RCl, for example RCl is an alkyl halide. So now what are the methods that will be used for conversion of alkyl halides like chlorides to respect to alkanes? See, you just treat this with the lithium aluminium hydride, so it will be giving us RH type of product, okay, alkyl halide giving alkane, okay. And the next we have discussed preparation of alkanes using Wood's reaction and also zinc catalyst like zinc metal and HCl like acid reagent will be taken here. This is also produces respect to alkene. For example, if it is methyl chloride, then you will get methane here, and here also you will get methane, okay. And if I treat same thing with ZnHZ, I can treat with zinc metal. So that is nothing but Franklin reaction we discussed. What do we mean by Franklin? 2 moles of alkyl chlorides with zinc metal gives RR type of product, okay. And even if you treat this with sodium in ether, in dry ether condition, okay, what happens again? This also gives RR type of product. If it is methyl chloride, you will get ethane in both cases, okay. Remember these reactions, okay. These are the preparation methods we have for making alkanes from a respect to alkyl halide, okay, right. And after this we have discussed about coal base electrolysis. What is this coal base electrolysis? Preparation of alkanes from carboxylic acid. For example, here I have carboxylic acid like RCOOH, okay. This carboxylic acid upon treating with a base forms a respect to salt, like if I treat with NaOH, forms carboxylate salt here, sodium carboxylate salt is formed. So this upon treating with CaO plus NaOH, you are going to get one type of product, or if I do a coal base electrolysis, this will be giving us one more type of product, okay. So now whenever we are doing this decarboxylation using calcium oxide like oxide and NaOH, this is called as soda lime. So just remove the CO2 part. What we need to remove from the carboxylic acid, remove CO2 part, remaining RH will be your product. For example, if this carboxylic acid is salt, here I am taking is acetate ion like sodium acetic acid, like acetic acid I am treating with NaOH, that gives this kind of product, sodium acetate will be forming right now. So that this particular acid upon treating with soda lime, what happens? Just remove this part. After removing the CO2 part, whatever the remaining part CH3 and H, that gives methyl and hydrogen, that is methane is formed, okay. Hope this is clear. Decarboxylation gives respect to alkyl group as an alkane. What I am saying, decarboxylation gives respect to alkyl group as alkane, that's it, okay. Now here you have 2 carbons, but product side you have only 1 carbon in the hydrocarbon that is formed, okay. And when it comes to carboxylic acid, upon coal base electrolysis, what will be the product formed? So it is very easy. Again look at this, just remove the CO2 from here, you are going to get a radical, R radical, like that. If you take 2 moles, you are going to get 2 radicals right now. So these 2 radicals will be pairing up to form RR type of product. So you will get whatever the alkyl group is there, just make it double like a dimer you can say, okay. If it is one R group, like if it is methyl group, you will get here ethane. If it is ethyl group, you will get here butane. See, ethyl means 2 carbons now, so double it, 4 carbons. 4 carbons means it is a butane, like that. Hope the discussion is clear. This is what we discussed in the last class. I just wanted to summarize everything that we discussed in the last class. in this first 10 minutes of the class. Hope whatever we discussed till now, everything is clear. Okay, so those who are in the session, if the things are clear, just mention clear in the chat box, and if you want me to cover anything other than this, you just tell me in the chat box, or if you want me to repeat anything, yes, feel free to express in the chat box. Okay, this is completely full productive session, no stupid things in the session, like purely discussion of content and solving the questions, making it more effective through a positive learning manner. Okay, right. So look at this, these are the classification, everything we have discussed. If you haven't watched last session, just go and watch that, definitely you are going to like it. I know you are going to learn many things from that. Okay, hydrocarbon session 1 over, this is session 2. Okay, right. See, for example, I am giving a question from yesterday's session. This is a molecule I am giving you. Here you have a double bond, here also you have a double bond, and I am saying you to hydrogenate this using H2PT catalyst. Okay, only one equivalent of hydrogenation is taking place. So it means out of this A and B sides, which will be reacting and what will be the product. Out of this A and B, I am saying only one double bond will be get hydrogenated with this hydrogen. So which one it is, either A double bond or B double bond. So it depends upon the reactivity. Again, reactivity is inversely proportional to its stability now. So more stable alkene, less reactive. If you want more clear explanation of this particular example question, you just watch yesterday's live session on this hydrocarbons. Definitely answer it, and I know you will definitely like that session. Okay, then next. See, these are the EAPCET questions that I have discussed in the last class. Okay, so if you do not know the answers for them, you go and watch it, definitely you will get to know everything regarding this. Okay, these are the questions we have discussed in the last session. Okay, right. Okay, Cowrie-House synthesis also I told you. So what do we mean by Cowrie-House synthesis? See, for example, I am giving you one alkyl chloride like this. Okay, so for example, here I am giving you methyl chloride. Yesterday only I discussed this methyl chloride, but I wanted to convert this methyl chloride to respect to alkane. I mean respect to alkane. Here let us say I want to prepare propane. What I want to prepare? I want to prepare propane, CH2 CH3, want to prepare this. So it means our reactant having only one carbon, but product is having 3 carbons. So number of carbons here is more now. So it means what we can say, we need to add a extra part. This extra part must be added to this methyl chloride to prepare this propane. Okay, so how many carbons are there? 1 and 2. So it means ethyl group must be added. So here we are using a reagent called Gilman's reagent. What is that? Gilman's reagent. So what is the formula of this Gilman's reagent? You can take 2 alkyl groups, dialkyl lithium cuprate. Okay, so this is the Gilman's reagent. See now what is R group I required here, alkyl group I required is ethyl. Na? So you can take diethyl lithium cuprate. Okay, if you treat this diethyl lithium cuprate with these, what happens here, you know these are metals, right? So if these are metals, our ethyl group is a non-metal, so definitely carbon is having negative charge. So now our ethyl group acts as a nucleophile and that attacks on this carbon and this chloride ion goes out. Okay, simply you will get a substitution reaction here, so that methyl chlorine going out and you are going to add here ethyl. Ethyl is nothing but CH3, CH2, that's it, and this methyl group as it is. Hope the discussion is clear and no confusions, right? Yeah, guys, if the things are clear, just click on the like button and share your comments. I mean share your feedback in the chat box, no issues. If you want me to discuss once again, I will be definitely repeating the same thing. Okay, let me check everything is clear or not, voice, audio, video. Yes, everything is clear. Right. The next thing here we will be discussing on Gilman's reagent, Cowrie-House synthesis is over. See, I am giving you one simple example to get an answer from your side. See, here I want to prepare butane. What I want to prepare? I want to prepare butane. So butane means 4 carbons na, like this. But the starting material here I have is propyl chloride, CH3, CH2, CH2, Cl I have. I want to prepare that butane. So what will be my Gilman's reagent? What is the alkyl group in this Gilman's reagent to be used to produce this? Okay, if you know the content, I mean whatever our discussed till now, if you got complete clarity on that, you just answer me what is our Gilman's reagent used to prepare this butane using this propyl chloride. Okay, see how many carbons required? 4. Here we have 3. So one more carbon must be added now. So Gilman's reagent must contain alkyl group having 1 carbon. That what is that carbon? So it is nothing but a methyl group. Dimethyl lithium cuprate should be used here as a reagent. Hope the discussion is clear. And now for example I have ethyl chloride. I want to prepare this butane. Now what is our Gilman's reagent? Just mention its answer in the chat box. Okay, right. Right, let us move forward here. And decarboxylation we discussed already, coal base also over, and these questions also discussed in the last session. And look at these. Okay, before going to that I just wanted to give you few more reactions. Look at this, a hydrocarbon A reacts with bromine. Till now whatever the questions appeared on the screen, that were covered in the last session. Okay, and this is a question I just wanted to solve in this session first. Okay, hydrocarbon A reacts with bromine by substitution reaction to form alkyl bromide. So what we got? Alkyl bromide we got. Okay, so now alkyl bromide which by Wood's reaction converted to gaseous hydrocarbon containing less than 4 carbon atoms. See what they are saying, a hydrocarbon A is taken, reacts with bromine by substitution reaction to forms alkyl bromide. That's it up to here. And these alkyl bromide which form alkyl bromide which by Wood's reaction is converted into gaseous hydrocarbon. Okay, so this upon treating with sodium in dry ether gives some hydrocarbon, gaseous hydrocarbon A. Okay, gaseous hydrocarbon A containing less than 4 carbon atoms is very simple. So they are saying substitution reaction less than 4 carbon. See if I take this one, see substitution reaction now. So substitution reaction of bromine, see if I have a hydrocarbon, substitution reaction of bromine takes place only on alkanes. Okay, by removal of hydrogen bromine atoms comes there. So what are the alkanes here? We have 1 and 4 are the options, we have alkane. So from this if I treat this with bromine for example, okay, you are going to get CH3, CH2 and Br. But if I do Wood's reaction with these, you are going to get a 4 carbons. But what they are saying, a final product should contain total number of carbons less than 4. It means this is having 4 now, so it means this is not our option. See if I take this particular option, I mean option 4, see this compound 4, so upon Wood's reaction, like first treat with bromine, then you will get CH3 Br, and now this upon treating with sodium, what happens in dry ether? Definitely this will get a CH3 coupled product like CH3 CH3. So this is our A, that is final product formed here, which is having less than 4 carbons. Now only 2 carbons are there. So what will be the suitable answer out of this 4? Our starting material here. So this is giving some product P. So what is our starting material here? Option 4. Okay, methane is our starting material A, here. Okay, so now the discussion of this question is also clear. Right, let's move forward. Tell me what they are saying, which of the following statements is correct regarding coal base electrolysis. Okay, how can you answer this? Tell me. Very easy. Very easy. See which of the following statements is correct for coal base electrolysis. So coal base electrolysis is a process in which a carboxylic acid converts into RR kind of product. It means this COOH group, like carboxylic group, is removed. Okay, hydrocarbons containing even number of carbon atoms are produced at anode. Yes, hydrocarbon produced at anode only. For example, I am taking COOH. So now this is giving RR type of product. If this R contains only one carbon, so total number of carbons are 2, just remove this, so you are going to get a 2. Okay, if I take 3 carbons containing 1, CH2, CH3, COOH. Now again remove this part, what I told you, remove this part, double this alkyl group, so it becomes ethyl butane. Na? So you are going to get a product having even number of carbons only in the product set, right now. So it means hydrocarbon containing even number of carbons are produced at anode. Yes, this is true. Right now, see, addition of like something like you take even addition, even plus even, what happens, like 2 plus 2, 4 now, like that. Whenever you are adding even plus even, you are going to get an even number only. Okay, and if you are adding odd plus odd also gives what, like 3 plus 3, 1 plus 2, 1 plus 1, 5 plus 5, all these are giving even only, no? So even plus even only, odd plus odd also even only. That's way, whatever the alkyl group might be having 4 carbons or 5 carbons, addition, like upon summing, you are going to get a even number only. So first option is perfectly true. Okay, hope the discussion of the first question is clear, first option is clear. The next, hydrocarbons containing odd number of carbon atoms produced at anode. No, hydrocarbons, no, this is incorrect. Okay, so product, hydrocarbon product is formed at anode and it will be having even number of carbons only. Okay, next, hydrocarbons containing even number of carbon atoms produced at cathode. No, this is also incorrect. Product, in coal-based electrolysis, we know hydrocarbon is a product formed at anode. Along with this, CO2 gas is also released at anode. At cathode, reduction takes place and forms H2 gas only at cathode. Okay, next. So this is also incorrect. Hydrocarbons containing odd number of carbon atoms produced at cathode. No. So only first option is correct for this particular question. Okay, hope the discussion is clear. Right. Right. And the next here, one more question I just wanted to show here is, sodium acetate on coal-based electrolysis gives ethane and methyl free radical is formed at cathode. No. So now what I told you, hydrocarbons are formed at anode. Na? So it means, first of all, if I take sodium acetic acid, sodium acetate, okay, sodium acetate means you just add here O minus Na plus. So now what happens on coal-based electrolysis? So this anion goes to anode side, which is positive terminal. There oxidation takes place, like CO2 gas will be removed, that generates a methyl radical. That methyl radical will dimerize, I mean they will couple and gives ethane as a product. What is a product formed? Ethane. And where do we got this methyl radical? Those are formed at anode now. So it means, see, acetate, sodium acetate on coal-based electrolysis gives ethane, that is perfectly correct, and methyl radical is formed at cathode. No, methyl radicals are formed at anode only, that will couple with each other. Each alkyl group will make a bond by pairing that free radical electron and gives a higher alkane like this. Methyl gives ethane, ethyl gives butane, like that. Just make it double the number of carbons, that's it. Okay, so this is at anode only. It means reason is incorrect, assertion is correct. So A is true, R is false. So option C will be your perfect answer. And this question we have discussed in the last class. So just try to solve this question. If you are unable to answer, no, do not worry, just go and watch my previous session on hydrocarbons. Okay, right. Right. And the next one more important way to get your alkanes, hydrocarbons. So what is that? See, treat your alcohols, treat the alcohols, whether it can be alcohol, whether it can be aldehyde, whether it can be a ketone or a carboxylic acid. Upon treating with a HI in red phosphorus, with red phosphorus, okay, in presence of red phosphorus, maintain temperature at 150 degrees Celsius. That will be producing respective alkane. So just remove this oxygen bond here, like only alkyl group is there now, you convert that alkyl group into RH form, that's it. If it is methanol, you are going to get methane. If it is ethanol, you are going to get ethane. Propanol, propane. Butanol, butane, like that. Okay. So here also just what they are doing, see how many carbons are there, R group is there, one carbon is there. So just convert this carbon into respective alkyl group. For example, see if this is methyl group, this is a carbon, so 1 2 carbon, so gives a ethane like product. Okay, so just convert the carbon into alkane type, like sp3 carbon you make by adding hydrogen, that's it. See, just remove this double bonded O and add 2 hydrogens here. Okay, that's it. It will be giving your respective alkane type product here. Okay, so carboxylic acid, now remove this COOH part and make this carbon as a methane, I mean methyl group like CH3 by adding hydrogen. Okay, hope the discussion is clear without having any confusions right now. So now what is this process here happening? Oxygen is removing now. See, from this alkyl group oxygen is removing. So from oxygen is removing, removal of oxygen is what? Reduction. Na? So alcohols, aldehydes, ketones, carboxylic acids undergoes reduction. Undergoes what? Reduction. Whereas our HI, iodide ion is there now, converting into I2. I2 means what? It is undergoing oxidation. So you can say this is an example of redox reaction. It is seeing, we are seeing one is undergoing oxidation, other one is undergoing reduction. Remember this reduction of alcohols, carboxylic acid, aldehydes, ketones using HI and red phosphorus medium, I mean presence of red phosphorus at 150 degrees Celsius gives respect to alkane. So whatever the number of carbons in reactant side, same number of carbons in product side also be observed here. Okay, hope the discussion is clear again. Right. Next, just guys tell me for this one example, one small example for you to practice and tell me your answer for this. See, I am giving you this kind of ketone. This is a ketone I am giving you. I am saying you to treat this with a HI and a red phosphorus at 150 degrees Celsius. A suitable temperature you take. Tell me what will be the product formed. So just what I told you, remove this double bonded oxygen, remove this part and make it as an alkane carbon like sp3 carbon. See, H2 and this is done. So make this as sp3 carbon like this by adding hydrogen. See how much, what is the hybridization here you have? sp3 now, that's it. So same number of carbons in reactant product side, but here it is sp2 carbon having oxygen, this is sp3 carbon having only hydrogens on it along with this alkyl group, that's it. This is the simple way you can understand the concept of reduction using red phosphorus and hydrogen iodide. Okay, right. Next. Here, and this is one of the very important reaction to be remembered. Okay, because we will be using it multiple times in many chemical reactions. Okay, see in the exam, examiner won't ask you direct question. By case, in some cases they may ask, but mostly they will give like this: A gives rise to B and B gives rise to C, C gives some D. So what is our D here, or what is our intermediate A or B or something like this? They will make a question. Okay, it's very easy. They will include this kind of Clemmensen reduction or this kind of reactions in between the this transformation. Okay, so now I will tell you this reaction. Later we will make this reaction series questions. Okay, you will definitely enjoy those reaction series questions if you follow these sessions perfectly. Okay, so just avoid all your confusions. Just focus here till the end of the session. Definitely you will get something new, and definitely you are going to answer the questions. Now see, after completing each and every session, take any PYQ question booklet of this EAP set from this particular chapter and solve any question. You are going to answer them without having any confusions. Okay, right. For example, let me show you this first. What to do whenever you are seeing an aldehyde or a ketone. What I am saying, aldehyde or a ketone. So this is an example of aldehyde and this is an example of ketone. So treat this with zinc amalgam. What I am saying, zinc amalgam in acidic reagent. Okay, so aldehydes, ketones. What I am saying, only aldehydes or ketones upon treating with zinc amalgam in acidic medium converts into respective alkanes. Okay, CH3 will be the product in the first case. Tell me what will be the product in the second case. Okay. Guys, those who are in live session, just mention your answer for this particular transformation. What will be the product form? See what is the change you are observing from here to there? See, I have converted this particular C double bond O group into CH3 group. That's it now. So here also you just convert this particular C double bond O group into CH2 group. So it means you can write R, C, R dash, and here C double bond O you remove and add 2 hydrogens above, 1 below. That's it. So a ketone is converting into respect to alkane. That's it. Now let us take some examples here. You can take acetone. So what is acetone here? CH3CO CH3. That's it. So these upon treating with ZnHg, zinc amalgam, in acidic reagent, what happens, tell me? So just this C double bond O is there now, that converts into respect to alkane. So just give its product CH3, C, CH3, and this will be now becoming CH2 group. That's it. So this is a small way, I mean small transformation that you need to be understand. When it happens only for aldehydes and ketones, when you are treating with zinc amalgam and acid reagent gives this kind of product. Okay, right. Okay, then next one will be same thing happens with one more reagent. What is that reagent used here? See, same transformation can also be done using hydrazine. What I am saying? Hydrazine. NH2 is called hydrazine in basic medium. What is that? KOH or NaOH is used here. KOH or NaOH is used under heating condition. For this hydrazine and KOH under heating condition, this particular transformation is called now, this is called Wolff-Kishner reduction. What is this? This is called, the second transformation is called Wolff-Kishner reduction. Wolff-Kishner reduction. Okay. So it means if you want to make this transformation from this reactant to product, like reduction of carbonyl group into respect to alkane in acidic medium, you can use our Clemmensen reduction. In Clemmensen reduction, you will be using zinc amalgam in acid reagent. Okay, if you wanted to do same process in basic medium, use Wolff-Kishner reduction where you will be having hydrazine, KOH under heating condition. Okay, high temperatures are required for this basic medium. Okay, so these are the two things must be understood. Okay, and must be focused. Why? Because see, we need to use these particular reactions depending upon what type of substrate we have. For example, substrate given having some acid sensitive groups, it means it might be react with acid. Okay, therefore you should not use this Clemmensen reduction. In that case you can use this Wolff-Kishner reduction. The best example I am projecting here, just look at here. See, I have an aldehyde here, but here I have CH2 Cl or OH, like this we have. Now I just wanted to convert these into respect to alkene. I mean I just wanted to remove that carbonyl group to methyl group. I want that transformation, and this alcohol should not be affected, should be remains as it is. Okay, for this particular transformation, what I did, I just converted this C double bond O into CH2. That's it now. What is that process we made? Just this newly this methylene group is added. So for this process, we have two types of reaction now. Clemmensen is there, Wolff-Kishner is there. But which one should be preferred here? So you need to prefer here Wolff-Kishner reduction instead of our Clemmensen. Why? Because this OH group is an acid sensitive group. Okay, what I am saying? This OH group is an acid sensitive group. So if you use this acid over here, this OH group goes out and generates a carbocation, and on that chloride might be attached, and here you will going to get a benzyl chloride. So but we do not want the transformation now, we do not want to disturb this alcoholic group. So you should keep it as it is. So it means it should not be affected. So for that purpose, if I use KOH only in basic medium, this base will not disturb this OH minus. So it will not be disturbed, only this group will be converted into respect to alkene like hydrazine, KOH under heating condition. So this is the way you need to understand what type of specific or what type of reaction or what specific reaction to be used for a given transformation. Okay. So hope the discussion is clear. Right. If the discussion is clear, just click on the like button, guys, again. Just click on the like button and you can share with your friends. Right. And the next thing we will be discussing, Wolff-Kishner reduction is done. So these are the things we have discussed till now. Only few I have covered here. Let us discuss remaining also. See, these things, everything is covered. See, you treat your alkyl bromide with lithium aluminum hydride, produces respective alkane, and treat alkyl bromide with sodium borohydride, that is also a reducing agent. They give hydride ion. So hydride ion act as a nucleophile, replaces these bromides. Okay, bromides. So gives a respective alkane. So now reduction of ethyl bromide also using zinc copper, okay, in acidic medium here, a zinc ACOH means acetic acid, so gives respective alkane. Okay, this is a Woods reaction. Alkyl chloride also gives an alkene. And Franklin reaction. Okay, Franklin reaction. What do we mean by Franklin reaction? So you are taking your alkyl halides. So these alkyl halides with dialkyl zinc. Okay, dialkyl zinc, or you just take zinc here, that will be converting into this form and gives a respective RR type of product. Okay, alkane only form. Next, Gilman's reagent Coriho synthesis also gives a respective alkane. So these things we discussed till now. Okay, and remember, along with that, given alkene upon treating with hydrogen, that is hydrogenation of alkenes or alkynes using a metal catalyst produces respective alkane. Okay, so particularly for alkenes, when we are using nickel as a catalyst, metal catalyst, we are calling it as Sabatier's-Sandrins process. Okay, right. Now they will ask, is it possible to prepare a methane? What I am saying, is it possible to prepare methane using your Sabatier's-Sandrins process? Is that possible? No, it won't possible, because that process is used to convert alkenes to alkenes. Alkenes definitely have 2 carbons now, but I am asking about methane preparation. So methane means only 1 carbon. So if I hydrogenate this, you are going to get ethane but not methane. So Sabatier's-Sandrins process or hydrogenation of alkenes, alkynes does not produce a methane. They will produce a minimum of ethane only. It starts from ethane only. Okay, remember these statements. Okay, next. Okay. Okay, and the next remaining we will discuss, no worries. Okay, again we discussed decarboxylation reaction. Next, coal-based electrolysis also covered, and using this HI and red phosphorus from alkenes, alcohols, ketones, carboxylic acids, it is done. And remember, this is one of the important reaction. You can see, this is a previously asked JEE question also. See, aluminium carbides and beryllium carbides, what I am saying, aluminium carbides, beryllium carbides, upon hydrolysis, what I am saying, upon hydrolysis gives alkane. That particularly the product formed is methane. From where? Aluminium carbide and beryllium carbide upon hydrolysis forms what? Methane gas, produces methane gas. Very, very important this point is. Okay. And if I use magnesium carbide, so magnesium carbide Mg3C2, so this upon hydrolysis produce acetylene gas. Remember these 2 points. Acetylene gas is produced with a magnesium carbide, whereas aluminium carbide, beryllium carbide produces methane gas. Okay, remember this point. And just now we discussed before 10 minutes itself, like Clemmensen reduction gives alkane and Wolff-Kishner reduction also gives alkane, but this is in acidic medium and it is in basic medium, that's it. Okay, from where? From respective aldehydes and ketones. Okay, so what is the conversion taking place? C double bond O group converts into C double bond O group converts into CH2 group, that's it. Methylene group is formed. Okay, yes, yes. Remember these points. Next, can you answer me this particular question on the previous discussion? See, why I have given this, already everything is covered. This is like you can make a short note out of this particular flow chart from this one and this one also, okay. So prepare your short notes whenever the chapter is completed. I mean, once if you are clear with the content, I mean complete topic, just make as much as small as possible, because your short notes should be very short, okay. It should not be lengthy as like your regular class notes, okay. If it is small, you feel more confident while studying, because you can finish it up very easily. Right now with every crystal clear point, like you just make one statement, that one statement should give you complete idea on that particular topic. That is how your short notes should look, okay. Right, now look at this soda lime and decarboxylation, soda lime decarboxylation. For this process, what will be the reagent used? So what will be the reagent used? We know it will be soda lime, and decarboxylation is nothing but this one 2, okay. And Clemmensen reduction, what is the process here? What will be the reagent used? Acid reagent and zinc amalgam. Clemmensen reduction is over. Wolff-Kishner reduction, hydrazine in basic medium. Woods reaction, sodium in dry ether. That's it. This will be the option. I mean, this will be the correct matching. A2, B, B1, the next B1, C4, C4, D3. That's it. Option 2 will be your answer for the question. Okay. Right. Next. Look at this, they are asking what is the boiling point order of the following molecules. See, all the given options 4 are alkanes only. Right now all of them are alkanes only, but if you observe the structures, it is like a straight line N-hexane, but this is a 2-methyl pentane now. It means 4, 5 over 2-methyl means like this, okay. This is what 2, 3 dimethyl butane. So 1, 2, 3, 4, 2, 3 dimethyl. So this is done, okay. So now see, it's a straight chain, branching, again branching. So it means if you see this straight chain, it is like a straight, but here branching increases. See, this is having more surface area covered, but it is having like coming like a spherical shape now, like it is becoming like a round, okay. Number of carbons in the long chain is decreased, means its surface area decreases. If surface area decreases, so the intermolecular forces between the molecules will be less, okay. So that will also be decreased. If it is decreasing, easily converts into vapors now. So boiling point will be less when you have boiling point will be less, or boiling point will be decreases upon the surface area decreasing or upon branching increases. If branching increases, what I am saying, if branching increases, so what I am saying, branching increases, boiling point decreases. Why boiling point decreases? Because it is becoming a spherical line shape, therefore surface area will be decreased, therefore intermolecular forces between the molecules decreases, so easily converts into vapors. That is what the concept here. If branching increases, boiling point decreases. See, this N-hexane is having a straight chain now, so it will cover more surface area. Therefore, between the molecules, this is one molecule, another molecule like this. Between the molecule, we may expect more intermolecular forces like this, whether might be van der Waals forces, whatever might be, but forces will be more when they have more surface area right now. So if more forces, they will be very closely attached, so separation required more energy. So more energy means more temperature means more boiling point is required. So N-hexane is having more boiling point, then next 2-methyl pentane. So this is more branches, so less boiling point. So 1, 2, 3 will be your answer for the question. So where do we have 1, 2, 3? 1, 2, 3 is first option will be your answer for the question. Okay. Right. Discussion is clear now? Right. Next thing here, physical properties. Just now I have explained you about physical properties like boiling point and all, okay. I mean boiling point, how to solve that boiling point type questions. See, Again remember, alkanes from 1 to 4 are gases. What I am saying, 1 to 4 are gases and 5 to 17 are liquid and above 18 are solids. What I am saying, 1 to 5 4 gases, 5 to 17 liquid, above 18 are solids. Okay. So now again, alkanes are non-polar compounds, like it contains only carbon and hydrogens now. So it means it's a non-polar compound. So it is a colorless, odorless, non-polar compound. Alkanes are colorless, odorless, non-polar compounds. Remember, and these are non-polar now, therefore they will only dissolve in non-polar solvents like benzene, CCl4 only, but not dissolve in polar solvents like water. Okay. So it is insoluble in water, you can say. Alkanes are insoluble in water. Simply you just take any oil or like petrol you can take. Okay. So petrol is nothing but isooctane, right? So if you take isooctane is an alkene. Okay. If you add to the water, will it dissolve? No, right? It will be separates into 2 layers right now. So our hydrocarbon like petrol will be appears at the top of the water right now. So 2 immiscible liquids like 2 separate layers will be seen. Okay, because they are each of them are having unlike charges. I mean, one is non-polar, another one is polar, so they won't dissolve. So just remember, like dissolve likes. So it means non-polar dissolves in non-polar, polar dissolves in polar. Okay, that's it. Like example, if I take alcohol, will it dissolve? Yes, it will be dissolves in water, but not like petrol or any diesel or any kerosene oil or any hydrocarbon like alkanes. I mean, alkanes and alkenes. Okay, hope this discussion is clear. So what I told you, boiling point directly proportional to van der Waals forces, van der Waals force directly proportional to molar mass. If more molar mass for a given alkenes, greater will be the boiling point here. Okay, this will be the order of boiling point. See, molar mass is more boiling point. Okay, if branching increases, surface area decreases, therefore intermolecular forces decreases, boiling point also decreases for a particular isomer. Okay, for a particular molar mass we can have different possible isomers now, like hexane, N-pentane, isopentane we have seen. So in that case, branching increases, boiling point decreases, you can remember. And remaining things about this particular substitution reaction, controlled oxidation, aromatization, pyrolysis, combustion, isomerization and reaction with steam, all this discussion will be continued in the upcoming session. So just stay connected with our our NEET World channel itself. So we will meet in the upcoming session on this hydrocarbons. Okay. So thank you for watching. Stay connected with us our NEET World channel and make your EAPCET, JEE and NEET preparations more effective. Thank you.